Alright, so number 10 on the review, with calculator, we're going to complete the square. Now listen, with the calculator, we know we could just do a solve feature. We could say, solve this equation when it equals -5 for x. And it will spit out the answer. If you want to do that, just so you know what answers you should get, I'm okay with that. But you will get no work points because you have to show completing the square. Okay, but at least you know what you're looking for. Okay, so real quick, let's go ahead and do this. Alright, so let's go to our calculator real quick just to see what answers we should have. Okay, so on our calculator, we're going to do menu 3-1. We're going to solve with -3x squared plus 7x is equal to a -5. We're going to solve for x. These are weird answers, but these are the answers that I'm looking for as far as in my final work. So this is what I'll say. If we write these answers off to the side, this one right here is really x is equal to a 7. This is a positive, plus 109 all over 6. This one's a little bit weird. If I distribute this negative, it's saying a positive 7 minus 109 all over 6. I only showed you this because in case that you have some weird fractions, I don't want you giving up on the problem. Especially if you have a calculator in front of you. I want you to still go for it, but I want you to know what you're looking for. Alright, so let's go ahead and keep going as far as showing the work that we're about to do. Alright, so completing the square. Step 1, get all the numbers over here and all the variables on the left alone. Done. Step 2, make sure that the coefficient, which is a, is what? 1. So I need to change this right now by dividing out from both the first term and the second term. This is where it gets real. I need to divide out this -3. So now I have x squared, and I have this -7/3 x. You with me? Now I'm going to leave space for completing the square and put a -5 left over on the right side. This is going to be my completing the square piece. You tell me. What's the equation that I use to complete the square?
b over 2 squared.
Perfect. b over 2 squared. It's very close, but it's not -b over 2a. That's something else. That's that vertex form from the standard. That's finding that x value of the vertex from the standard form of the quadratic. Alright, here we go. So what I'm going to do is I'm going to take the new b term when a is 1, and I'm going to put that here and say b is going to be divided by 2. And already you see that there's an ugly fraction that's about to appear. But if I divide by 2, it's the same as multiplying by 1 over 2. Keep, change, flip. And if I square it, what I'm really looking at is squaring this -7 over 6, which would give me 49 over 36. Okay? 49 over 36 goes here. It is a plus. Now I know, yeah, this one you can't simplify yet. But what I know is, my next question, the things I'm going to be looking at on the key or on your test when I'm grading it, is how much did you end up adding or subtracting to the other side? Okay? Am I going to add 49 over 36? I'm not. The reason why is because this is not a 1. If it was a 1, I would. But because it's a 3, I have to multiply these two to see how much am I actually adding to the right side. Or subtracting in this case. So with the calculator, you could put negative 3 multiplied with 49 over 36, or you could do this by hand. This 3 and 36 would reduce to 12, so this would give me a negative 49 over 12. Okay, and if you put that into your calculator, you should get that, unless you press Control Enter and you get a decimal. Keep it like the fraction. If I'm adding a negative, I can change this just simply to subtracting, so I get something that looks like this. Are there any questions from what we just did? Okay, from here, we will complete the square by keeping this negative 3 out in front, the square root of the first term, the square root of the last term, and borrow that first sign. Okay, and then last but not least, we can add or subtract these together. 5 has a common denominator of 1, and I'm only doing it by hand to help you out with more practice so that you can practice other things that are not in calculator. I need to multiply it by a form of 1, which is 12 over 12. So to get this a 12, this will become a 60. Okay? And this is where that negative 109 appears over 12. I'll then, from here, divide both sides by a negative 3. So again, the negative divided by a negative, that's going to become a positive. And 109 divided by 12, here we go, 109 divided by 12, divided by 3, oops, is going to be the same as multiplying by 1/3. So I have this as a running answer. Over here, 109 over 12 times 1/3 will become 1 over 9 over 36. In your work, the next step I'm looking very closely to, if I square root both sides, I will have x minus 7/6 is equal to what? Perfect. But what is he missing? Something very important, the plus and the minus. The plus and minus. When you square root both sides, you need the plus and minus there. Okay? A lot of people forget that. That square root, the way it's written, can be broken up to the top and the bottom. The square root of 36 becomes 6. I have a plus or minus. And last but not least, I'm going to add that 7/6 over to the right side. So it'll look like a positive when I move it. You with me? And sure enough, this is the positive and the negative version that you see over here. And yes, you could write them either way. That's where I knew the question was coming. As far as two fractions, do you want me to write it as two fractions? Or do you want me to write it as one big fraction? To me, I probably would most prefer that one right there. But all of them are equivalent and all of them are okay.
So because when you go back to like where you had the square root of 36,
Yep.
you took that 6 out. Is that where it's like dividing by 6? Like
Yep.
And then because it was also negative 7/6, the 6's are just 6.
Yeah, so you know how when we used to add fractions like this that have a common denominator, we would get that?
Yes.
So it's basically doing that,
Okay.
going back and forth between those two forms.
Because you're just dividing the whole both of them. pretty
Yep,
much.
all over 2a. In other words, all over the same common denominator.
And if those had different denominators, you'd have to split it.
Yeah, or multiply by a form of 1 to get them the same and bring them together.
Yeah.
I'd probably just keep it split. Any other questions? That's a very good one to do.